Oxygen is by far the most common heteroatom in functional groups. Anytime you see oxygen in a molecule and you're trying to identify what functional group it is, the first thing you want to ask yourself is what type of bonds are they? Are they single or are they double? And then what is the connectivity of oxygen? In other words, what is it directly bonded to? So let's look at the simplest functional group with oxygen, which is known as an alcohol. The alcohol functional group occurs when we have an oxygen with a single bond to hydrogen, and that oxygen is also singly bonded to a carbon-containing group. Now, often we will refer to this carbon-containing group as R, or the rest of the molecule, because we will focus on the functional group. So one of the things I want to point out about oxygen and its bond to hydrogen here, it's a very common group. And so when we have oxygen singly bonded to hydrogen, that's known as a hydroxyl group. Oxygen always fulfills the octet rule. So on this graphic here, we see two single bonds to the oxygen, which signifies a total of 4 electrons around the oxygen. Oxygen also has 2 lone pairs. We often don't expressly write those lone pairs, but as chemists, we know that they're there and they're impacting the overall geometry. For example, this bond angle here between the oxygen-carbon bond and the oxygen-hydrogen bond is less than 109.5. 4 electron pairs around a central atom mean they want to be as far apart as possible, which would be a bond angle of 109.5, but the lone pairs are better at repelling, so that smooshes these two bonds together for a bond angle that's less than 109.5. The simplest alcohol is methanol, so notice the meth for 1 carbon, and it ends in -ol, meaning it's an alcohol. And we take a look at the 3D structure in the ball and stick model. The oxygen in the ball and stick model is always going to be color-coded as red, whereas the carbon will be black and the hydrogens will be white, sometimes gray if they're on a white background. In this 3D structure, we see the carbon in methanol has a hydrogen coming toward us. The dash represents the hydrogen on the other side of the plane, and the carbon, hydrogen, carbon, oxygen, oxygen, hydrogen bonds are all in the plane of the paper. Notice that the oxygen does not expressly have its 2 lone pairs written, but it clearly impacts the geometry of the molecule in any alcohol. Here's another common alcohol, ethanol. So eth means 2 carbons and it ends in -ol, so it's an alcohol. And this is the type of alcohol that's found in alcoholic beverages, and it's also the alcohol that is added to gasoline. So the ball and stick model gives us a better sense of how this molecule actually looks like in 3 dimensions, and it also clearly indicates this bent angle between the oxygen and the carbon and the oxygen and the hydrogen.